This is an introductory lesson about electrostatics. Electrostatics is a branch of physics which deals with the study of charges at rest. In electrostatics, we are dealing with a property of matter called charge. And we are familiar with the fact that charges of two types, positive and negative. And like charges repel and unlike charges attract. Charges are characterized by, first one, charge is quantized. The meaning is the charge of an object is a multiple of a basic value E equal to 1.6 into 10 raised to minus 19 Coulomb. It is actually the charge of an electron or a proton. Charge is having another property, additivity. Additivity means the total charge of an object is the sum of individual charges. And third property is conservation. Conservation means charges can neither be created nor be destroyed, but we can transfer from one body to another. And the total charge of a body is the sum of individual charges. We cannot create or destroy charge, and the charge is actually an integral multiple of the basic charge 1.6 into 10 raised to minus 19. We can charge a material by friction. While rubbing two objects, charge will be transferred from one object to another. The object which is more electronegative will be getting more electrons and it will be negative, and the other object will be positive. We can charge a material through electrostatic induction. This is a method in which we can charge an object without the actual contact. Coulomb's law is about the force of attraction or repulsion between different charges. According to Coulomb's law, the force of attraction or repulsion between two charges is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. And here the proportionality constant is 1 by 4 pi epsilon 0. Here epsilon 0 is the permittivity of free space and its value is 8.85 into 10 raised to minus 12. And the total value 1 by 4 pi epsilon 0 can be obtained as 9 into 10 raised to 9. So don't forget the equation. According to Coulomb's law, the force of interaction between two objects and which is equal to 1 by 4 pi epsilon 0 q1 q2 by r square. If you are considering the medium, see actually the Coulombian force is depending on the medium, and here K is actually called dielectric constant. So the force of attraction or repulsion between two objects within a medium is force in air divided by dielectric constant, and K is having value 1 for air or vacuum. According to principle of superposition, the total force over an object can be found by using vector algebra. The total force, the force of attraction or repulsion over an object can be found using vector algebra. Vector algebra, you are familiar. The vector sum is actually root of f1 square plus f2 square plus 2f1 f2 cos theta. Here theta is the angle between the two forces. Okay. Now let us think about some previous questions. The ratio of force between two small spheres with constant charge in air and in a medium of dielectric constant K. See, this is actually a question which lets you know the fact that Coulombian force depends on the medium. Here, the dielectric constant is given as K. So, the answer for this question is the force of attraction between two objects is actually F equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square. If there is a medium, then the force can be written as 1 by 4 pi epsilon 0 K Q1 Q2 by R square. So here K is there at the denominator, and by dividing these two equations we will get an answer K is to 1. Now another question. A soap bubble is given a negative charge, then its radius. So when you think about this question, we are giving negative charge to a soap bubble. So when we are giving negative charge, the charges will be uniformly distributed and the charges will repel each other. So the radius will be increasing. Then another question is about superposition principle. Four charges are arranged at the corners of a square ABCD. They are asking you what is the force on a charge kept at the center O. First, let us think we are going to keep a plus 1 Coulomb at the center. Then, when we are placing a plus charge at the center, the plus Q at point A will repel towards the point C. The same way, plus Q at C will repel the plus charge towards A. Since these two forces are equal and opposite, the forces will cancel each other. But that is not the case for minus 2Q and plus 2Q. So, when we are placing a plus Q at the center, plus 2Q will repel it towards the point D. Minus 2Q will attract it towards D. So the total force will be acting towards D. Then you will ask me, sir, when we are keeping a negative charge at the center, then the force will be towards B. Now we can think about the options. Here there is no option towards B. So the correct answer is along the diagonal BD. Okay. Now another question. In the absence of other conductors, the surface charge density. See, surface charge density is something like this. It is actually the ratio of charge to surface area. Okay. So sigma equal to Q by A. Then it is directly proportional to the charge and inversely proportional to surface area. So the option is C. Then fifth one is we are having two charges, plus 2 Coulomb and plus 6 Coulomb, and they are repelling each other with a force 12 Newton. Then they are asking if each charge is given minus 2 Coulomb. Now you can see plus 2 Coulomb and minus 2 Coulomb. What is the sum of plus 2 Coulomb and minus 2 Coulomb? 0. So what is the force between 0 and then we are adding minus 2 Coulomb to plus 6 Coulomb. What is minus 2 plus 6? It is plus 4. So what is the force between 0 and plus 4? See, force between 0 and something is 0. So the correct answer is 0. Okay. Thank you.